This is the Arrhenius equation in 2 minutes. The Arrhenius equation is a formula that links rate constant with temperature and activation energy. It's K is equal to A e to the power of EA over RT, where K is the rate constant, which is variable units, EA is the activation energy in joules per mole, temperature is T in Kelvin, R is the ideal gas constant, which is 8.31 joules per mole per Kelvin, A is the Arrhenius constant, and e to the power is a mathematical function known as an exponential, which you can find on the calculator. If you were to increase the value of the activation energy in the formula, then K would decrease, and if you were to increase the temperature, then K will increase. Another form of the formula is ln K is equal to ln A minus EA over RT, and you get this by applying a natural log to the formula. A natural log is just an example of a mathematical function, and it's the inverse of an exponential. So if you ever want to move an exponential to the other side of an equation, you can apply an ln to the whole equation, and vice versa. When you make activation energy the subject of the formula, you get RT brackets ln A minus ln K, and to make temperature the subject of the formula, you get activation energy over R brackets ln A minus ln K. In this example, it asks you to calculate activation energy, so you want the form of the rearranged equation where activation energy is the subject. So that's EA is equal to RT brackets ln A minus ln K. You can now sub in the values that are given in the question. So that gives 8.31 times 308 Kelvin brackets ln 4.7 times 10 to the 13 minus ln 1.35 times 10 to the minus 4. And that gives a value of 103,429 joules per mole. You can also use the ln version of the equation to help with graph questions, as you can rearrange the equation as ln K is equal to minus EA over R times 1 over T plus ln A. The reason you do this is because now the equation is in the form of y is equal to mx plus c, which is a straight line graph. So you can plot a graph of ln K against 1 over T, and that will give you a straight line graph where minus EA over R is the gradient and ln A is the y-intercept. Plotting a graph like this will give you a straight line with a negative gradient. So where the line crosses the y-axis, it gives you ln A. And the change in y over change in x, which is the gradient, gives you minus EA over R. So for example, if you had a y-intercept of 3.1 and a gradient of minus 2.2, you can say your ln A is equal to 3.1, and you can use the inverse to find out what A is. So that would give you A is equal to e to the power of 3.1, or exponential of 3.1. Putting that into the calculator gives you a value of 22.2 as the Arrhenius constant. And if the gradient is minus 2.2, we can say that minus EA over R is equal to minus 2.2, and we can rearrange that to find what EA is. So that would be 2.2 times 8.31, which gives you an answer of 18.29 joules per mole. This was obviously a very quick summary. For a longer, more detailed explanation of the topic, check out the link to the full lesson and subscribe to my channel.